Students, we are going to talk about the chapter 8, water. Water is important for our lives. Without water, life is not possible on the earth. And it is found in the abundance, means in the access on our earth. We can say it's covering the third, fourth part of the earth. And also we can say our body is also 7% out of 10, 7% water is present. And even in the fruits and vegetables, 9 parts are water and only 1 part other things are there. Then water, we can say it also helps to maintain the temperature of our bodies and also the atmosphere. And then we use it for many things, like we can say cooking, drinking, washing, and also we use in the agriculture like for irrigation and the dairy farming, and in the industries also as a solvent, reactant and a coolant. So then sources of water on the earth are ponds, rivers, lakes, seas, ocean and the groundwater. These all the sources are replenished, means maintained by the rain. And then so we can say next is water are universal solvent. Universal solvent means number of substances can be dissolved in the water. Not any other solvent is dissolving such a number of substances. Because of this property only, water help to dissolve, means help rivers to dissolve many minerals from the soil. When the rain will be there, many minerals from the soil dissolve in the rainwater. This rainwater reach to the rivers and finally reach to the seas. So that is why our seas and ocean are the vast source of minerals and other soluble substances. How are solute dissolved in a water? We can say when any solute means any, we can say sugars, salt, anything can be there. When it mix with the water, okay, or any other solvent, we can take any other solvent in place of water. We can say these solute molecules, they become separate and they hide in the molecules of the solvent. Solvent molecules have some intermolecular spaces, means some spaces are there between the molecules of water. So sugar molecule will, we can say, fit in that spaces, that intermolecular spaces, and hide themselves. So that is why we can say even the level of the water will not be changed. So now next is, okay, water is superior to the other solvents. So we can say it has the solute, means solute we can here take a salt, NaCl. Solute fragments into molecules and radicals, means it helps the solute to break up into molecules or radicals. Radicals means element which is containing a charge, positive or negative, that is called the radical. Water molecules, they are electrically neutral. Electrically neutral means they does not contain any charge as per. If they having any charge, like we can say positive charge over the H charge hydrogen ion and same the equivalent negative charge on the oxygen atom. So they both cancel each other. Such molecules are called the polar molecules, which are uncharged or we can say neutral. So water is a polar solvent because it does not contain any charge. So we can say due to this polarity, water molecules, they experience a Columbus attraction. Columbus attraction means electrostatic force of attraction. Electrostatic force of attraction means charge based attraction, means positive and negative charge they are attracting. So for the polar solutes, okay, we can say like that. Here we can say this H is having a positive charge, it will attract the negative charge particles. That is called the electrostatic force of attraction. So then including those radicals also, we can say when any solute like this, we can say sodium chloride is there, so common salt is there, it we can say dissolve in the water. So then water molecule, they will cling to the solute molecule. Water molecule will be attached to the solute molecules and then they will take away from them. Means we can say the sodium chloride, when we dissolve in the water, first it will break up into positive and a negative ion. Okay, then this positive charge of water will attack the negative ones and then this positive charge will be attracted to the negative charge of water. So then they both, we can say, in other words, we can say sodium ions are surrounded by the negative charge oxygen ions and negative charge chloride ions are surrounded by the positive charge hydrogen ions. So that is why sodium chloride will be dissolved in the water. So many other examples are also given in your book. You can see like a sodium sulfate, okay, and magnesium sulfate. All these radicals we can say dissolve in the water. So all the salts can be dissolved in the water. And number of bases like sodium hydroxide, potassium hydroxide, calcium hydroxide, these also soluble in the water. They also too made up of the radicals. And then the next is solutions, suspensions and the colloids. So we can say solutions, suspensions and colloids. They are important type of the mixtures, means mixtures. So then solution we can say is a homogeneous mixture. Homogeneous mixture means we can say solute is dissolved properly, just equal distribution of solute in the solvent. That is called the homogeneous mixture. So solution is a homogeneous mixture of one or more solutes with the solvent. As you can see in the picture, we can see the color is equally distributed. It's not there. Okay, color is on the upper side maybe more content or maybe lower side more content. Nothing like that. There is a equal distribution of the color in the container. So that is why solutions is a homogeneous mixture in which one or more solutes with the solvent. As we can say, when we are dissolving a common salt in a glass of water, we sip when this water, we feel that is a salty equal in the first sip and same way salty at the last sip also. And same way for dissolving sugar in a glass, we feel it's a sweet as in the first sip, same way sweet at the last sip also if the sugar is properly dissolved. So then solutions has some important characteristics. As the solution is a transparent, okay, means it's a transparent, we can see clearly on the other side, and then we can say it passing through a filter paper, means solutions can pass through the filter paper. And then we can say, and then that there will be a mixing, any solute which we are mixing, they do not settle at the surface, it will properly dissolve in that, वो properly इसमें dissolve हो जाएगा. Then we can say they very smaller in size, solute particle size will be very smaller. It's minus, we can say 10 to the power minus 9 is there, that much small size of the solute molecules. So then we can say, then next is the suspension. Suspension is a heterogeneous mixture. Heterogeneous means solutes are not properly dissolved. While we are stirring, on that time is equal distribution is there. But while we leave the stirring, जब हम उसको हिलाना छोड़ देंगे, on that time we can say the solute will be settled at the surface. Okay, solute will be settled at the surface. So that is why it's a heterogeneous mixture. And then here we using, we can say solute we are using as a term disperse phase. And then next is solvent, we are using it as a dispersion medium. Okay, here means in place of solute and solvent, we replace this term with the disperse phase and the dispersion medium. So we can say suspension is the heterogeneous mixture of one or more dispersed phases in the dispersion medium. As we can say, example we can say the muddy water. So when you are dissolving a mud in a water, you can say while you are stirring, on that time mud is equal distributed, you can see the color of the water will be browny like copper. But when you leave it for 10 minutes, you will see mud will be settled at the surface. Same, if you are taking a chalk, when you dissolve this chalk in the water, you will see while you dissolving, on that time the water has a milky appearance. But while you stop dissolving, this chalk particle will be settled at the surface. Then we can say it's not necessary only solid can be dissolved in the liquids. Sometimes a liquid can be dissolved in a liquid. As we can say, oil can be dissolved in the water. Okay, that is called the emulsion. And sometimes a liquid can be dissolved in the gas. As you can say, some gases are present in the water also. Okay, and that we can say water in the air also. That is a example of a fog. Okay, fog we can say in that some other water, okay, molecules in the air they become cloud. Then gas in a solid in a gas, that is called the smoke. As smoke you can see the gas is there and some solid particles are there. So then particle size is more, okay, it's very bigger, we can say 10 to the power minus 6 is there in the suspensions. Now the third one is the colloids. Colloid is also a homogeneous mixture, means particles are equal distributed in one or the more dispersed phases in a dispersion medium. Very common example is a milk. You see fat is dissolved in the milk, but we are not able to see, it's properly distributed. Then we can say, and then apart from this, some water, or in water jams, jelly, whipped cream, gelatin. Gelatin means it's kind of protein in the water. These all are the examples of a colloid. And colloids are not transparent. And in that, particles do not settle at the surface. There are many in between them. They do not settle at the surface, and the size of the particle is intermediate between minus 10 to the power minus 9 and 10 to the power minus 6 is there.